SpaceX has poured over $2 billion into the Starship project and has been working on it for more than 6 years. Compared to what other companies have done in this time, SpaceX has been very successful. But building a rocket, especially one as big as Starship, is never easy. No matter how much time and money are spent, there's always something that needs fixing. Even after the recent fourth flight, several issues popped up that need attention. It's actually good that SpaceX found these problems early on because now they can work on fixing them. In this video, we'll look at what went wrong during the fourth flight and what SpaceX is doing to solve these problems. But before we dive in, make sure to subscribe to our channel for more updates on Starship and SpaceX's other exciting achievements. The fourth flight of SpaceX's Starship was a major success. It was the first time SpaceX managed to land both the Super Heavy booster and the Starship itself after launch. This achievement came after many improvements and tough testing. Even though one of the 33 engines failed right after takeoff, the vehicle still completed its mission. This shows how much the design has improved compared to earlier tests. For instance, during the first and second orbital tests in 2023, SpaceX faced bigger problems, like losing control before and after staging, meaning issues during launch and after the rocket stages separated. The second test also had problems, with the booster facing trouble before it could land and the Starship upper stage failing to land. The third test flight on March 14, 2024, still had challenges but showed some progress. 6 out of 13 Raptor engines on the Super Heavy booster shut down early due to a blockage in the liquid oxygen filter. Despite this, the flight managed to open the Starship payload bay door in space and perform a small propellant transfer demo. During the fourth flight, most engines worked well during both ascent and descent. The new hot staging ring helped the booster separate smoothly. All 33 Raptor engines on the booster fired up, though one shut down shortly after liftoff. Despite this, the flight was a success. This flight was special because it was the first time both the Super Heavy booster and the Starship achieved controlled splashdowns. This is a big step toward making both stages of the rocket reusable. The hot staging ring helped with a smooth booster separation, and the Starship's heat shield performed better, though some tiles were still lost during re-entry. This is a concern but shows where improvements can be made. The landing flaps, despite some damage, did their job helping with the controlled descent of the spacecraft. In response to these challenges, SpaceX plans several upgrades. Elon Musk has confirmed a focus on improving the heat shield system, including redesigning how the tiles attach to keep them secure throughout the flight. Another key area is the internal hardware, especially parts like the roll control thrusters and systems involved in landing. Improving these areas is crucial for better descent and landing. The countdown to the fourth launch started early in the morning, with the launch window opening at 7 a.m. local Texas time. The prep included loading propellant, with liquid methane and liquid oxygen being pumped into both the booster and the Starship. Final checks by the SpaceX flight director ensured everything was ready for launch. As the countdown hit 0, the Raptor engines fired up, and the Starship lifted off from the launch pad at SpaceX's Starbase in Boca Chica, Texas. The ascent was smooth, showing big improvements in propulsion and stability. The vehicle passed through maximum dynamic pressure, or max Q, without issues. This phase had caused problems in previous flights. During this recent flight, the stage separation went as planned. The Super Heavy booster, with its 33 Raptor engines, completed its job and detached from the Starship. After stage separation, the Super Heavy booster performed a controlled descent, aiming for a soft splashdown in the Gulf of Mexico, doing a landing burn to slow its descent. This was a big step toward reusing the booster, even though it splashed down rather than being recovered on land. The Starship continued on its own, reaching space and then starting its controlled descent toward a planned splashdown in the Indian Ocean. During its descent, the Starship faced intense heat and pressure. The upgraded thermal protection system was tested, and the data collected will be crucial for future missions. The vehicle's descent was closely monitored, with engineers paying special attention to the heat shields and other structural components. The flight ended in a controlled splashdown in the Indian Ocean. One problem during this launch was that one of Starship's flaps got damaged during descent. Live camera views showed the heat shield on the flap burning away, sending debris across the camera's view. This debris eventually cracked the camera lens, affecting the visual feed of the descent. This flight was very successful, especially compared to the third flight. During Flight 3, the upper stage began to roll uncontrollably, stopping the vehicle from relighting one of its 6 Raptor engines. However, thanks to its connection to the Starlink satellite internet network, another part of SpaceX's business, the rocket was able to stream back high-def camera views showing its re-entry through a blanket of plasma. According to SpaceX, the lack of control resulted in a tough re-entry, with much more heat than expected on both protected and unprotected areas. The likely cause of the unplanned roll was clogged valves for roll control. SpaceX has since added more roll control thrusters to upcoming Starships for better control and redundancy. The onboard cameras on the Starship upper stage during Flight 3 showed the vehicle surrounded by plasma as it re-entered the atmosphere on March 14, 2024. Meanwhile, the Super Heavy booster from the last flight also had issues, with 6 out of 13 Raptor engines shutting down early during the boost back burn. SpaceX found that the blockage in the liquid oxygen supply caused a loss of inlet pressure in the engine oxygen turbopumps. With the success of Flight 4, Elon Musk teased an ambitious goal for Flight 5, catching the Super Heavy booster using the launch tower's so-called chopsticks. Flight 4 was important not only for SpaceX but also for NASA. The rocket will take center stage for the Artemis 3 mission, which is targeting September 2026. Lisa Watson-Morgan, the manager of the Human Landing System program, and her team continue to work with SpaceX to understand the rocket's development for the Artemis 3 and Artemis 4 missions. The path to Flight 4 was filled with improvements from previous missions. SpaceX's commitment to iterative development was clear as they addressed the issues from Flight 3. The unexpected roll of the upper stage during Flight 3, caused by clogged valves, led to adding more roll control thrusters in future Starships. These changes aim to prevent similar problems. The re-entry phase of Flight 3 was especially tough, with extreme heating causing significant damage despite the vehicle's protective tiles. This led SpaceX to rethink its thermal protection strategies, focusing on keeping the vehicle intact during re-entry. Flight 4 aimed to build on these improvements. The mission's goal was to achieve a deeper re-entry into the atmosphere, pushing the Starship to handle higher levels of thermal stress. Despite losing some tiles and a damaged flap, the mission provided valuable data for future designs and refinements. The Super Heavy booster's performance in Flight 3 highlighted areas for improvement. The early shutdown of 6 out of 13 Raptor engines during the boost back burn was a critical issue. SpaceX found that the blockage in the liquid oxygen supply caused a loss of inlet pressure in the oxygen turbopumps. To fix this, SpaceX improved propellant filtration in future Super Heavy boosters, ensuring more reliable engine performance. There's a lot of excitement for Flight 5, especially with the goal of catching the Super Heavy booster using the launch tower chopsticks. This new approach aims to reduce the need for landings and make recovery easier. If successful, it would be a big step toward full reusability for SpaceX. Flight 4's success is not only a milestone for SpaceX but also crucial for NASA's Artemis program. The Starship rocket will play a key role in the Artemis 3 mission, which aims to return humans to the Moon. The collaboration between SpaceX and NASA highlights the importance of Starship's development for lunar exploration. SpaceX's orbital launch mount at Starbase, which was heavily damaged during the first test flight, showed resilience thanks to new protective measures. After the first flight, the pad had a massive crater because it lacked a flame trench to deflect exhaust plumes. To prevent more damage, SpaceX installed a water-cooled steel plate beneath the launch mount, which successfully protected the pad during Flight 4. And that's all for today's update. If you enjoyed watching and found it useful, please make sure to subscribe to our channel and hit the like button. Thanks for watching, and I'll see you in the next one.